All right, let's dive right in. Today, we're going to put on our detective hats and solve a classic mystery. You've just been handed a brand new data file. So, where on earth do you even start?
You know the feeling, right? A new file lands in front of you, a CSV, maybe an Excel sheet, and it's just sitting there. It's packed with potential clues, but looking at it raw, it's kind of overwhelming. But don't worry. Every great investigation starts with one simple first step. And that's our whole mission for today. We're not going to jump the gun. We're not going to run any fancy analysis. Not yet. First, a good detective has to survey the scene, get the lay of the land, and just understand what evidence they're even working with. So, it's time to open our very first case file with one of the best tools in the entire data detective toolkit, Pandas.
Okay, so every detective needs a place to organize their clues, to pin up photos and notes, right? Well, in the world of data, we have our own version of that, our investigation board.
And that is the Pandas DataFrame. Now, seriously, forget any complicated definitions you've heard. Just picture a big grid, like a spreadsheet or a table. That's it. It's a place where every single piece of evidence, every data point, has its own spot, all neatly organized into rows and columns. This simple structure is what makes it so incredibly easy to see exactly what you're dealing with.
So, our board is all set up and ready to go. Now we just need to get our case file, all that raw data, up onto the board so we can actually start looking at it. And for today's case, we've got a good one. We're going to be looking at salary data for 397 college professors in the US from back in 2008 and 2009. It's the perfect little mystery for our first investigation. So, how do we get this file onto our board? You're going to love this. It's basically one line of code, but let's just break it down into three simple parts. First, we import our tool. Import pandas as PD. That's just us telling our program, hey, we need the pandas library, and we give it that little nickname, PD, just to make life easier. Second, we actually open the file using pd.readcsv. And third, we store all that juicy data into a variable. We'll just call it df for DataFrame. And that's it. Boom, our evidence is loaded. All right, the case file is open. It's on our board. Now, what's the first thing a real detective does when they arrive at a crime scene? They don't just zoom in on the first tiny clue they see, right? No, they take a step back and get a quick overview of the entire room. And Pandas gives us two perfect commands for exactly this. If you want to see the first few clues, you just type df.head. Think of it like flipping to the first page of a report. And if you want to see the very last few clues, you use df.tail. It's just a super fast, simple way to make sure everything loaded right and to get a feel for the data. And here's what we see. Just by running df.head, we immediately see the columns. These are the types of clues we're working with. We've got the professor's rank, their discipline, years of service, sex, and of course salary. See, just from that one quick glance, we're already starting to understand the case.
Okay, that was our quick scan of the scene. Now it's time to get a little more serious and check the file's vital signs. We need to know the basic facts before we can really start digging in.
And the first question is always about scale, right? I mean, just how much evidence are we even dealing with here? For that, we use something called .shape. Notice there are no parentheses this time. It's an attribute of our data, not a command. So .shape gives us back two numbers. That first one, 397, that's our number of rows. You can think of these as our individual records. So in this case, we have evidence on 397 different professors. And the second number, 7, well, that's the number of columns. These are the different types of clues we have for each of those professors, their rank, discipline, salary, and all that. So our whole investigation board has 397 rows of records and 7 columns of clues. Okay, and this next part is absolutely crucial. It's not enough to know that we have clues. We have to know what kind of clues they are. Is a piece of evidence just text, like a name, or is it a hard number we can do math on? Getting this right is everything. And for that, we use df.dtypes. This command is like an X-ray for our data. It checks every single column and tells us what type of data is in there. Here we see two main types. Object is basically how Pandas says this is text, so rank and sex are text. And int64 means it's an integer, a whole number, like salary or years service. This is so important because it stops us from making a silly mistake, like trying to calculate the average of a column of names.
Now, as you start your own investigations, just a quick heads up on a few common traps. Sometimes a file just won't open because of something called wrong encoding. Or maybe a file is so huge it slows your whole system down. And a classic one, the file is missing headers, so all your clues are mislabeled from the get-go. These initial checks help you spot those traps right away.
So let's recap. We've loaded our data, we've taken a quick look, and we've checked its vital signs. We've basically done all the foundational work of a real data detective. But you might be asking, why does any of this matter?
Well, let me tell you, this initial inspection is your single best defense against massive headaches down the road. By taking just 5 minutes to do this stuff up front, you can catch that the salary column was accidentally read as text, or notice that half your file is missing. This simple, methodical start will literally save you hours of pain later. It makes sure your whole investigation is built on a solid foundation. And there you have it. You now have the skills to properly open any case file that comes your way. You've loaded the evidence and you've surveyed the scene. The foundation is set. So the only question left is, now that you have this data laid out so clearly on your investigation board, what questions will you ask to solve the case?